In this video, we're going to investigate this series. So suppose I were to put a random number, let's say the number 9 into this x, the number 9 into this x. Will this series converge or will it diverge? So looking at this series, if I were to put, let's say, the number 34 into the x, the number 34 into the x, will this series converge or will it diverge? So in this video, we're going to investigate this series. Well, to investigate it, we will need the ratio test. So with the ratio test, we always need to know this value here, the value of this. With the ratio test, we always need to know this value here. Well, our an plus 1, our next term, divided by our current term, well, an plus 1 will be this, and then our an will be this. So now it's just a matter of tidying this up. So here you've got one fraction divided by another fraction. So that's the same as you getting that same fraction and then multiplying by the reciprocal of this fraction, which is this. So now it's just a matter of tidying this up. So when you look at this, you will need to tidy this up, because this can then tidy up with this. Well, what does 2n factorial even mean? If you have 2n factorial divided by 2n plus 2 factorial, what does that mean? Well, in the past, we had something like this, n factorial over n, let's say, plus 2 factorial. You see, this is easy to understand because if you were to put, let's say, something simple there, let's say the number 4. Well, 4 factorial would mean 4 times 3 times 2 times 1, and then put a 4 into here. That would be 4 plus 2. That would be 6. So 6 times 5 times 4 times 3 times 2 times 2 times 1, and then these will cancel out, leaving you with n plus 1 and then n plus 2. You see, in the case of n factorial over n plus 2 factorial, that's easy to understand. But here you've got 2n, and then here you've got 2n plus 2. So to investigate this, and to investigate this, we would put something simple into the end. Let's put the random number 3 in. Put something simple into the end and see what, and try and investigate. So 2 times 3 would be 6 factorial, and then for this part here, if you put 3 into the end, that would be 2 times 3. That would be 6. That would be 6, and then you add an extra 2, and then you add an extra 2. So what that means is, well, 6 factorial. So what that means is this thing divided by this thing. In our case of n being 3, this would be 6 times 5 times 4 times 3 times 2 times 1, and then this thing here would be 6 plus an extra 2. So it would be 6 plus an extra 2. It would be 8. It would be 8 times 7, 6, 5, 4, 3, 2, 1. And then you can see that these would cancel out, leaving you with just these two terms. So remember, hang on, n is 3. So this is our n here. So this is our n here. So remember, 2n factorial would be all these here. 2n plus 2 factorial would be all these here. But don't forget, this is our n, and this is our n. So when you have 2n, so that this is our n here. So this is our n. When you times 2, it will then take you to the 6, and then you add an extra 2. You add an extra 2, 1, 2. So all these would cancel out. All that's left would be, well, don't forget, n starts at 3, so 2n would be 6. So this here is our 2n, and then what's left would be 2n plus 1, and then this last one would be 2n plus 2. So when you simplify this, it actually becomes, hang on. So when you try and simplify this divided by this, it actually becomes 2n. So this is in our example, it would be 7 and 8 for this one here. In our example, it would be these two that would be left. Anyway, tidying these two blocks up. If you merge these two together, it will then give you this. It will simplify to this, and this stays the same, and this stays the same. So imagine this as being as being one block multiplying another block. So that's this 2 here, and then this is exactly the same as this. So these two will cancel each other out, leaving you with this. So now you taking the limit or the product of the two is the same as you taking the limit of this. Well, we've done this many times. So from here that will then take you to here. Well, the limit as hang on, bear with me. The limit as n n tends to infinity of this will be, well, as n tends to infinity, this whole lot will be 0. So this whole block here will be 0. So here you've got one block multiplying another block. Well, this block here is 0. So 0 times whatever this is, then the whole thing will be 0. So going back to the very start, we were trying to investigate this. To investigate this, we would use a ratio test. With the ratio test, we need to know this value here. Well, as it turns out, the value, regardless of what you insert into the x, the value of this will be 0. So even if you put 9 into the x, the limit of this will be 0. Even if you put 3,452 into the x, the value of this will be 0. Well, with the ratio test, remember, with the ratio test, if the value of this equals 1, then we can't conclude anything. But in our case, the value of this, in our case, the value of this is 0. In our case, our value here is 0. Well, 0 is less than 1. So therefore, the original will converge. The original series will converge, because in our case, the value of this is 0. Well, 0 here is less than 1. So we are looking at this scenario here. In our case, the value of 1. Well, it can't be this scenario. It can't be this scenario. It has to be this thing here. So what that means is, regardless of what you put into the x, the value of this will be 0, meaning that the original series will converge. So the original series will converge regardless of what you put into the x. You can put 273 into there. If you put 273 into here, this value here will be 0. Well, 0 is less than 1. Therefore, the original series will converge. So overall, the original series will converge regardless of what you put into the x.